Using the derivatives of sine and cosine. In this lesson, you're going to learn about finding the equation of the tangent line to the curve of a sine and cosine equation. Now remember, when you're finding the first derivative and plug in the x value from my point, you're finding the slope. You also need to remember the special triangles when dealing with trig. And you also need to remember the equation formula is y minus y1 equals m times x minus x1, and that would be in brackets. So we'll work through this first example here. It says find the equation of the tangent line to the curve of y equals 2 sine x at the point pi over 6 comma 1. So the first thing we need to do is find the derivative, and then we'll substitute in the point the x value of pi over 6 into the derivative, which will give me the slope. And then lastly, I'll form the equation. So the derivative of y equals 2 sine x. The derivative of sine is cosine. So my derivative is 2 cosine x. Then I'll substitute the point pi over 6 into the x value, and I need to use my special triangle here. So cosine pi over 6, if I refer to my special triangle, which I have handy either on a formula page or I've memorized, cosine pi over 6 is root 3 over 2. So I get 2 times root 3 over 2. The 2's cancel, and root 3 is my slope. So by forming the equation, I have my slope of root 3, and I also have my point from above, pi over 6 comma 1. Substituting these values into the general equation, y minus y1, so y1 is 1, equals m, which is the slope of root 3, and x minus x1, which is pi over 6. Then I continue to simplify, so I'm going to distribute root 3 into the bracket. Since I have a denominator of 6, I'm dealing with fractions. I multiply by 6 all the way across the equation, because what I do to one side of the equation, I need to do to the other. And then make your equation equal 0. Then I'm going to do a second example. It says find the equation of the tangent line given pi over 4 comma 1, and here's my equation. Y equals cosine squared x over sine squared x. And I need to remember that cosine squared x is the same thing as cosine x all squared and sine x all squared. So I'll need to use the quotient rule when I take the derivative of the equation. So make sure you have lots of space. When I go to take the derivative of this, I leave the denominator, sine x all squared, use the power rule, 2 times cosine x, and I subtract 1 from the exponent, and the derivative of cosine is negative sine x, minus cosine x all squared, use the power rule, so 2 comes in front, sine x to the power of 1, and the derivative of sine is cosine x. And then I square the denominator, so the denominator becomes sine x all to the power of 4. Then I need to simplify here, so I see how I have 2 and a negative sign in the first part of the term. So I'm going to bring that negative 2 out front. And same with the right-hand side, after I'm going to bring the 2 out front as well. Now I look for some common terms here. Can I take out a GCF? Just to simplify this a little bit more. And I notice that I can factor out a -2. There's a GCF there. I can factor out a sine x, and I can factor out a cosine x. So my GCF in the numerator is -2 sine x cosine x. And what I'm left with in brackets is sine squared x plus cosine squared x. And I know that sine squared x plus cosine squared x is 1. And I can cancel a sine x with a sine x in the denominator, leaving me 3 sine x's in the denominator. So my simplified answer is -2 cosine x over sine x all cubed. But in order for me to find the slope, I need to plug in the x value of pi over 4 into the derivative. Cosine pi over 4, according to my special triangles, is 1 over root 2. And sine pi over 4, if I look at my special triangles, is also 1 over root 2. Mathematically, I need to simplify, and my slope is -4. So I have my slope of -4, I have my point of pi over 4 and 1, and I'm going to plug these into the general form for an equation. Y minus y1 equals m times x minus x1. I do my substitution. Distribute the -4 inside the brackets and make the equation equal 0. And there you have it. There's the equation of the tangent line.